Good evening, everyone. This one is AS level physics, unit 2, topic wise question DC electricity. In this session, I will discuss some questions related to DC electricity. That's the first topic of unit 2 of IAL physics. In the first question, which row in the table shows the total resistance if two 5 ohm resistors are connected in series and in parallel? So, if you have two 5 ohm resistors and they are connected in series, so the combined resistance in series is the sum of individual resistance. So this is 5 ohms and the other one is also 5. So the sum will be 10. So in series it will be 10. So either C will be answer or D will be answer. But what about in parallel? Like if two or more resistance or resistors are connected in parallel, then the combined resistance, if it's 2, then it will be product divided by sum. If it is more than 2, then we can add the reciprocals and then invert. So a 5 ohm resistor and another 5 ohm resistor both are connected in parallel. So the combined resistance will be the RT or total resistance, it will be product divided by sum. But keep in mind this formula is only valid for two resistors. If more than 2, we cannot use this formula. So 5 multiplied by 5 divided by 5 plus 5. So 5 multiplied by 5, 25. And that divided by 10. So the result will be 2.5. So D is the right answer. In question 2, the current potential difference graph for an ideal diode is shown. So this is for ideal diode. The graph has been labeled at 3 separate points X, Y and Z, at which point is the resistance of diode is infinite. So, or we cannot define that. So how we can work out, as we know resistance is voltage divided by current. So when you check the position X, the current is 0. Position Y also the current is 0. So R is equals to V divided by, the potential is there but the current is 0. So V divided by 0, and anything which is divided by 0, that is infinite. So at position X and at position Y, both have, in both cases the diode is having infinite resistance. But point Z, because there is a certain value of voltage and current, so it's a finite. So the correct answer is A. In question 3, a copper wire has a cross-sectional area of 5 into 10 to the power minus 7 meters square. There is a current in the wire of 0.93 ampere. Copper has 8.4 into 10 to the power 28 conducting electron per meter cube. That's the number of the charge carriers, value of n. Which of the following give the magnitude of the drift velocity? So we have the formula I is equals to NAQV, where I is the current, N is the number of charge carriers per unit volume, A is the area, Q is the charge or electron or charge of the particle which are responsible for conduction, that's electron, and V is the drift speed. So if V is the drift speed, we need the drift speed. So it will be I divided by ANAQ. So I is the current which is 0.93. N is the number of the charge carrier per unit volume which is 8.4 into 10 to the power 28 multiplied by area which is given 5 into 10 to the power minus 7 meter square multiplied by charge of 1 electron which is 1.6 into 10 to the power minus 19 coulomb. So it matches with option D. In question 4, negative temperature coefficient thermistor is connected in series as shown. The temperature of thermistor is increased. Which row of the table shows how the reading of voltmeter 1, V1 and V2 and current changes? So what is the relation between the temperature and the resistance for thermistor? They are inversely proportional. So if the temperature is increased, the resistance of thermistor will decrease. And because it's a voltage divider circuit, so if the resistance here decrease, the voltage here will decrease in comparison, because the total sum of V1 and V2 will be constant. So if V1 value is decreasing, V2 value will increase. And what about the current in the circuit? Because the combined resistance will be the sum of resistance of thermistor plus the resistance of fixed resistor. So resistance of thermistor is changing, the fixed resistor is constant, as its combined resistance is R1 plus R2. So value of R1 is decreasing, so combined resistance will also decrease. So if the combined resistance decrease, the value of the current will increase. So A is the right answer, that value of V1 will decrease, value of V2 will increase, and the reading of the ammeter will also increase as the total resistance of a circuit is decreased. This is a structure question related to DC electricity. A car battery is constructed using 6 cells connected in series with a combined EMF of 12V. What is meant by the term EMF, electromotive force? So what is the definition of electromotive force? It is work done per unit charge or work done to unit charge. So the work done to move or moving unit charge around the complete circuit. That is known as electromotive force or EMF. The next question, a student sets up the circuit as shown using the car battery. The student adjusted the variable resistor until the reading on the voltmeter is 11.81. The reading on the ammeter is 9.83. Calculate the internal resistance. So this is the EMF. We know voltage here, the external voltage, that is 11.81, and we know the current in the circuit, that is 9.83 amps. So the formula which relate the external voltage and total EMF with voltage drop internally, that EMF is equals to V plus, because EMF is the total voltage, V is external voltage, plus IR, voltage drop internally. So we have this 9.83, this is 11.81, the current is 9 point, sorry, the total EMF is 12, by mistake I wrote 9.83. So total, this is EMF is 12, 11.81, current is 9.83, and resistance R is there. So it will be 12 minus 11.81 divided by 9.83, that will give us the value of internal resistance, which will come out as 0.0193 ohms. The next question, the student adjusted the variable resistor several times and record a corresponding values for ammeter from the ammeter and voltmeter. Describe how the values can be used to determine the internal resistance of the battery using graphical method. So what student should do? So student should plot a graph between voltage on y-axis and current on x-axis. So this is how the graph will appear. Then the y-intercept, this y-intercept, when the current is zero, the maximum voltage will be there. That will give us the EMF. So maximum voltage of the cell, that is given by the y-intercept, and the gradient will be negative internal resistance. As we know, EMF is equals to IR plus V or V plus IR. When we compare with the equation of straight line, when we rearrange the equation, we can say V is equals to minus IR plus EMF. Then we'll compare Y is equals to MX plus C. So Y axis we have voltage, X axis we have uh, the current. So our gradient will be minus R, and the y-intercept is equals to EMF. Next question. With use, the internal resistance of a battery will increase. Eventually, the power available from a battery will become too small to be useful. The student calculated the power available from battery of 9 volts and internal resistance 0.1 ohm when connected to 5 ohm resistor. He concluded that when the internal resistance had risen to zero point 0.5, the power dissipated in the 5 ohm resistor would reduce to 70% of its original value. Determine whether the student conclusion is correct. So how we can work out whether the student conclusion is correct? For part C, so we know power P is equals to I square R, and we want to explain the idea that the external power has reduced to 70%. So P is equals to I square R. So in the beginning, the 9 volt EMF is there and the internal resistance is zero point 0.1 when a 5 ohm resistor is connected. But then he concluded that when the internal resistance rise to zero point 0.5, so what we will do, basically the current in the circuit will change. We will have two currents. So example, we have a 5 ohm resistor, and this is zero point 0.5 ohm, zero point 0.1 ohm in the beginning, the internal resistance, and the EMF is equals to 9V. Then what happened? The internal resistance has changed to zero point 0.5 ohms. So this one is zero point 0.5 ohm. This is again 5, and EMF is equals to 9. So first what we will do, we'll find the current in this circuit, the first circuit. And how we can find the current? So current is V is equals to IR. So I is equals to V divided by R. So that will give us, we have the voltage 9. And what about the combined resistance 5 plus zero point 0.1? So it will be 5.1. This will be 5.19 divided by 5.1. This will give us the current, that is 9 divided by 5.1, is equal to 1.76. So 1.76 ampere is the current in this circuit. And when we find the current in the second circuit, again that will be EMF divided by combined resistance. The total voltage is 9 and the total resistance is 5.5. So 9 divided by 5.5, that will give us 1.63. 1.63 ampere. So this is having 1.63 amperes. Now, when we find the power here, P is equals to I square R. So power of this circuit, the circuit 1, in which P is equals to I square R. So 1.76 square multiplied by resistance, that is 5. So 1.76 square multiplied by 5, this will give us 15.548, so 15.5 watts. And we find the power for circuit 2, P is equals to I square R. So the circuit 2, the current is 1.63 square multiplied by resistance 5. So 1.63 multiplied by 5, so it will give us, and this power will be 13.2. So 13.2 divided by 15.5, that is the total change in the power, for because in the question he conclude that when internal resistance has risen to zero point 0.5, the power dissipated in a 5 ohm will reduce to 70% of its original value. So when we calculate in original power, initial power was 15.5, and the final power when we are calculating for circuit 2, that is coming out 13.2 watts. So what is the change in the power? That is 13.2 divided by 15.5 into 100. So it will come out as 86%. So student suggestion that it reduce to 70%, but it does not reduce to 70%. So student statement is not true with reference to the values. Moving on to the next question. Which of the following statement about the physical quantities or units is correct? Current is a derived quantity, that's wrong. It is the standard SI base quantity. Power is a derived quantity, that's true. Coulomb is a base unit, Coulomb is a derived unit. Volt is a base unit, volts is also a derived unit. So these are the right answer. So question 7, which electrical component has the current voltage graph as shown? So what is happening here, because when current is on y-axis and voltage on x-axis, so slope is reciprocal of resistance. So here the slope is increasing, it means the resistance is decreasing. And which component the resistance decreases when we increase, when the temperature or voltage increase here? So that is the thermistor, because when the charges are passing through, so the temperature increase. As the temperature increase, its resistance will decrease. And the resistance decrease, it means the slope should increase. In question 8, a small metal cube with side of length x is connected in a circuit. The current through a cube between the two opposite faces is I. The potential across the cube is V. Which of the following give the resistivity? So it's a cube and all the sides of the cube are x. So this one is x, x, x. So the formula which relate resistance with resistivity R is equals to L by A. And the formula which will relate voltage and current with resistance, so V is equals to IR, so R is equals to V divided by I. So when we compare the two equations, you can say V divided by I is equals to rho, length is X, and the area X into X, so it will be X square. So this will cancel with X will go there in multiplication, so it will be Vx divided by I. So it matches with option A. So for question 8, A is the right answer. Two copper wires are placed in series in a complete circuit. The electron in two wires have different value of the drift velocities. Which of the following must be different for having a different for the two wires? So there is a different drift velocities and two copper wires. So when they mention two copper wires are there, it means they should have the same charge carrier because the material is same, so value of n will be same. So if they are connected in series, so when they are connected in series the current is same, so there cannot be current. Then the factor on which the drift velocity actually depends, we have the formula I is equals to NAQV. So basically drift velocity depends on the area through which it is passing. So current is same, number of charge carrier same, Q is constant. So the thing which is different is the cross-sectional area. So B is the right answer. In question 10, the circuit shown as a potential divider including a battery of negligible resistance, a light-dependent resistor or LDR and a potential PD across is measured using a voltmeter. Which of the following statement about the circuit is correct? If the resistance of LDR is half, the voltmeter reading will be half. That's not true. Why that's not true? Because if both have the same resistance, because they are in series, so if both have the same resistance, then the voltage divide will be same. But if this resistance is half, so the voltage will always divide in ratio, so that's why this is not the correct statement. Increasing the light intensity would decrease the voltmeter reading. If you increase the light intensity, the resistance here will decrease, so voltage across LDR will decrease. In comparison, voltage across fixed resistor increase because it's a series circuit in which the voltage divide or sum of two voltages will be same. So if the value of V1, if I say this is V1 and this is V2, so value of V1 is decreasing, the value of V2 should increase so that the sum will remain 12. So that's not the right statement. Increasing the light intensity would have no effect. That's wrong as well. The voltmeter reading added to potential across LDR will always be 12. That's true because when we add the reading across the voltmeter of fixed resistor and LDR, the total sum will be equal to the EMF if we neglect the internal resistance. In question 11, a student is given the circuit diagram as shown. Calculate the value of the voltmeter reading. So this is a voltage divider circuit. How we can find the value of the voltmeter reading? So the formula which relate is, if I say this is V1 and this one is V2. So V1 is equals to resistance of that part divided by sum of the resistance of the circuit into combined voltage V. So that is 55 kilo, 12 and 55 kilo, 12 kilo and 55. So 55 into 10 power 3 plus 12 into 10 power 3 into combined voltage. The combined voltage is 1.5. So this will give us the value of V1 reading on voltmeter. So that will come out as 1.23. The student set up the circuit and observed that the reading on the voltmeter is lower than the value calculated in A. So in practical, he's not getting the same answer like 1.23, this answer, but in practical, the reading of the voltmeter is less than what he calculated. So what could be a reason for that? Because what we neglect here in a circuit, we take an ideal condition that the component, the wire, the connection wire are not having any resistance. But in practical, they also have resistance, or the cell might have internal resistance, so some of the voltage drop internally. So what could be the two reasons why the value might be lower than the expected value? Number one is the resistance of connection wire. And what will be the effect of this resistance of the connection wire? So there will be some voltage drop across the wires. And the second, the internal resistance of the cell is neglected here. So cell will have internal resistance. So the terminal voltage is less than 1.5 V. Four identical resistors are shown, A, B, C, and D, are placed in a circuit as shown. Determine the power dissipated in each of these resistors, and it's of 6 marks. So basically, to get the power dissipation, we know you should note the current. Each resistance is 2 ohm. So this one is 2, 2, 2, and 2. So first we will find the combined resistance of the circuit. So these two are in series. So this will be 2 plus 2, 4, and this is in parallel. So it will be product divided by sum. I'm solving it here on the left hand side. So 2 and 2 are connected in first in series. So 2 plus 2, 4, and 4 and 2 are in parallel. So it will be product divided by sum. So 4 multiplied by 2 divided by 4 plus 2 or 2 plus 4. That will be 1.33. And that 1.33, because it's combined, 1.33 is in series with 2. So the combined resistance of a circuit will be 1.33 plus 2. That will be equal to 3.33 ohms. So the total current in the circuit V is equals to IR. So I is equals to V divided by R. The combined voltage of a circuit is 10 and the total resistance is 3.33. So the total current is 3 amperes. So the total current which entered the circuit is 3 amps. Because we'll use the formula P is equals to IH square R to get the power. But what about the current in this branch? Because in parallel the current divides. So current will divide between these two components, between the two branches. And what will be the division? So according to the resistance, it will divide. So this resistance is 4 ohm and this resistance is 2 ohms. So how we can find the current which is passing through this side. So either we can find the voltage as it is of 6 marks, like we know the combined resistance of this part, as the current will divide between the 3 ampere will divide accordingly. This is this branch less resistance, so more current will be there. This will have more resistance, so less current will be there. So the current through D, current through D will be equal to 2 by 3 of 3 amperes, which is equal to 2 amps. So if 2 amp is passing through 2 amp is passing through this one, the remaining 1 ampere will pass through the other branch. And then we'll find the power for each. For A, for power we'll use I square R. So for A it will be 3 square multiplied by 2. 3 square is 9 multiplied by 2. That's equal to 18 watts. For D it is 2 square multiplied by the resistance, that's 2. 2 square is 4 multiplied by 2, so that is 8 watt. For B and C will have the same power because they have the same current and resistance. So the current is 1 square multiplied by resistance 2, so that is equals to 2 watt. And for C also it will be 1 square multiplied by 2, that's also equal to 2 watt. So this is the power which is dissipated across each resistor in the circuit. The next part, explain without further calculation what would happen to power dissipated by resistor A if the resistor D was disconnected. So if we remove the resistor D, it means all will come in series. So if all will come in series, the total resistance of a circuit, what will happen? The total or the combined resistance of a circuit will increase. As the combined resistance of a circuit will increase, the current in the circuit will decrease, so the power dissipation will be less. Because originally, when we calculated the current was coming out 3 amps. But this is without calculation, we don't have to do calculation. Originally, the current was 3 amp when D was there. But now when 2 ohm and 2 ohm are connected in series, the combined resistance is 6. So the current will be 10 divided by 6, which is equals to 1.6. So the current in the circuit is approximately half. So if the current, so basically removing or disconnecting D will increase the total resistance of a circuit, which reduce the current and the power dissipation. So it will increase the total circuit resistance, which reduce the current and power dissipation. If the resistor in the circuit used in a wire replaced with a filament lamp, the resistance of each lamp would be different depending on the potential across it. Explain in terms of particle why the resistance of filament increases as the potential across the filament lamp increases. So as we increase the voltage, the resistance of a filament lamp changes. So what could be a reason? So basically, as we increase the potential, the current will increase, and as the current through a lamp will increase, there will be more collision between electrons and lattice, uh, or the ions present, and that the ions will move faster, vibrate faster, and current is having a heating effect. So as the current increase, it will heat up filament. So the sequence should be, because that's when current increase, the filament temperature increases, more collisions will be there, the lattice vibration or at ions vibration increase. That's why the resistance is increased. In question 13, the unit of power is what? Which of the following is included in SI, base unit of the power? So power, what is power? Basically, power is work done per unit time, or it is joules per second, and joules itself, it is Newton meter, and Newton is kilogram meter per second square. SI, because which of the following included in the SI base unit? So this is a drive unit. This is also a drive unit. So either B will be answer or D. But when we write for power, as we know, power is equals to watt, the unit of power, or it is joules per second. Joules is Newton meter per second, and Newton itself is kilogram meter per second square. This will be multiplied by meter and second. So when we solve, kilogram meter square second raised to power 3, or kilogram meter square second minus 3. The base unit involved kg, not ampere. So B is the right answer. Question 14. The diagram shows a combination of three resistors X, Y, and Z. Which of the following gives the total resistance? Because first they are in parallel, so it will be product divided by sum. So it will be Y multiplied by Z divided by Y plus Z. And then that is added to X. So product divided by sum and then added to X. So C is the right answer for question 14. In question 15, the diagram represents or shows a circuit used to determine the internal resistance and EMF. Corresponding potential V and I were taken and adjusted. A graph was plotted on V on y-axis and current on x-axis. So this time the current is on x-axis and voltage is on y. Which of the following is correct? The area underneath the graph is the total energy dissipated. That does not give, because area will be product and that will be the power. The gradient of the graph is r. Gradient is not r, it is minus r. And the graph shows V and I are directly proportional. No, that will have a linear relation but not a direct proportional, because as the voltage is decreasing, terminal voltage, the current is increasing. Y-intercept shows the EMF, that's true. So the y-intercept, the maximum value is the EMF. Question 16. The diagram shows a circuit determine the internal resistance. The resistance of variable resistor. Which of the following gives the current in the cell? So how we can work out the current in the cell? We have the formula EMF is equals to IR plus I and capital R. So if I take I common, so EMF is equals to IR plus capital R. or EMF divided by R plus capital R, because the total current is total voltage divided by total resistance. So it is equals to, it matches with option C. So these are some questions we discussed from 1 to 16 related to Unit 2 topic DC electricity. The next session I'll discuss more questions from this assignment.